to become the next Sir Isaac Newton or Albert Einstein? Learn from the master, Refath Bari. Watch his videos to achieve your dream.
So easy that today I'm naming my lecture a quick shot lecture, which means a lecture under 30 seconds. Now,
wait, what?
That's right.
30
yes.
seconds?
Now today we're doing the cofactor expansion of vector cross products.
That will take 30 seconds?
Yeah, I call it the, what is it?
Like 15.
Cofactor expansion. And of course, this is a special lecture with only a lesson. So cofactor expansion of vector cross products. Now, first and foremost, for the do now, I'd like to ask my students what they think the cross product means. Okay, so students, would you like to explain what do you think the cross product is?
I totally don't know. And if I haven't practiced from an awesome website called Brilliant.
Alright, well, hopefully you know what the cross product is from the last couple of lectures that we've been doing. If you don't know, let me give you a brief overview. The cross product of two vectors in R3. By the way, the cross product only exists in R3, so if you have two vectors,
what about R4?
No, only in R3.
So only exclusively R3?
Right, as far as I know. No.
Also, you said this was a quick shot lecture that was under 30 seconds. It's already been 2 minutes.
That's fine. Now, if I have two vectors, u and v, in R3, right? And both of my vectors are in R3, the cross product of these two vectors is going to give me a third vector that is mutually perpendicular to both of my original vectors. And the magnitude of that vector is going to be is going to be the area spanned by these two vectors, okay? So hopefully that gives you a good sense of what the cross product is. Now today we're going to take a look at the cofactor expansion of the vector cross product, which is hopefully not too bad. Hopefully something you should be used to by now. So the cofactor expansion is going to be the way we take the cross product of three-dimensional vectors. So for example, if you're given vectors, something like this, let's say A, B, C cross D, E, F, there's no given formula that you can use to find their cross product, right? You can't use the two-dimensional way of what the cofactor expansion is. Thank you. So the cofactor expansion is quite simple. We're going to start with our three basis vectors, right? This one's going to take up a little bit of space. So why don't I just go ahead and write it down. So we're going to start with our three basis vectors, which are what? I hat, j hat, and k hat, right? But of course, this is not it, right? We're going to write down our two vectors, which we want to take the cross products of, right? So let's go ahead and do that, okay? So I want to take the cross product of vector ABC and DEF. As you can see, I've taken their transpose and I've written them horizontally. Taking the transpose is going to take a vertical vector and transpose it into a horizontal vector, which is what I'm writing down for my vector cross product. Okay. So now, here comes the big stage. Okay. So first and foremost, here's what we're going to do. I'm going to take my I hat and consider these vectors B, C, E, F. Okay? Hopefully everyone sees what I'm doing. Okay? Oh, let's put a cap on this marker. Anyway, so this is all gonna equal.
Can you use this one? I don't have a cap for this one.
Oh.
So keep using this one.
Oh, people can see this short. Okay, that's okay. So let's see. I'm gonna write down I hat. So I hat times whatever vector I have under consideration. In this case, it's this 2 by 2 matrix B, C, E, F. All of this minus what? Well, now I'm gonna take this j hat, and then I'm gonna take AD and CF as such. Okay. So I'm gonna subtract j hat times AC df, and finally, what am I going to do? I'm going to add back my final matrix, which is going to be k hat times this 2 by 2 matrix of order 2, right? So I'm going to write plus k hat times BCEF, okay? Make sure that we didn't make any mistakes, because first and foremost, when we took I hat, we took the same thing. So when we take k hat, we have to take the opposing matrix. So Actually, we have to take A, B, D, E. So make sure you don't make any silly mistakes like that. A, B, D, E. Now we're ready to go ahead and actually expand this out, right? So let's go ahead and write this down. A, B, C cross D, E, F is simply going to be I hat times all of this. And what is all of this? Well, this the cross product of a square matrix of order 2 is simply going to be BF minus CE. Likewise, we're going to perform the same operation on this square matrix of order 2 minus J hat times AF minus CD. And finally, for my last matrix, what I'm going to write is plus K hat times AE minus BD, folks, alright? And that is it. That is the formula for the vector co-expansion of cofactor expansion of vector cross products. Alright, hopefully I didn't mess that up. Okay, so this is the formula that you need to memorize or just keep in mind whenever you're taking the cross product of two three-dimensional vectors. Okay, so keep in mind this formula. If you forget how to derive it, just write it out in the cofactor expansion form. Good luck and thank you for
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.